Very good evening. Today, I am continuing my last lecture. The topic thread, whether multi-threading in Java. In last class, I discussed about what is multi-threading, and at the discussion of the thread definition, we came to know a thread is similar to a program that has a single flow of control. It has a beginning, a body, and an end. It executes its commands sequentially, and so far the program that we have written all are single threaded program because it consists only one thread, that is main. Better to say it's a main thread, and each and every program must have at least one thread. This part we have discussed in my last lecture, and we already discussed there are two approaches. Using of these two, we can implementing this thread concept in Java program. And the beauty of the Java program is Java supports multi-threading. The first approach is by extending thread class, and the second approach is by implementing runnable interface. And in the last lecture, I have already discussed about the program, rather implementation of multi-threading using extending of thread class. Today I will discuss few more topics on this multi-threaded program. So let me start with the concept, rather life cycle of thread. This part we have already discussed, the difference between multitasking and multi-threading, and how we can create a thread by extending thread class and by runnable in using, or rather implementing runnable interface. That part is not discussed yet. Today I may discuss if time permits. Fine. So let me start the discussion with life cycle of thread. That's a very important question of your syllabi. First, let me explain the diagram. Then I am coming to the different states of life cycle of a thread. Look, first state is the newborn state. Fine. I hope the screen is visible to you. First state is the newborn state. Second state, one is running, another one is runnable. Fine. One more state is the block state, and one state is the dead state. So once again I am repeating, the first state is the newborn state of a thread. Second is it is basically the running state. It can be decomposed into two parts. One is running, another one is runnable. Why it is decomposed, I'm coming to that point later on. Another one is a block state and another one is a dead state. Fine. So the state of this life cycle of thread can be defined in this 5 steps: newborn state, runnable state, running state, block state, and dead state. So in the last class, what we have done, we just extending a thread class. We have created a thread class, and I discussed the run method is basically the heart of a thread. The thread body that we want to execute in a form of a thread must have to write inside this run method. And after creation of this object, we have to call start method on that thread object. Fine. So let me explain the concept with respect to this diagram. When I am creating a thread, rather when I am creating an object of a thread class, not only the thread class, rather the class that extending the thread class, that is a newborn state of a thread. Fine. So when we are basically creating an object of a thread class, that we have already done in my last program or last lecture, that is nothing but the first step is it's a newborn state, that is thread object created. And after that, what we have done, we have called the start method to start that thread. And when the thread is in a newborn state, it is not scheduled for running. Fine. It is not scheduled for running. So in this situation, what may happen? You may approach for any of these two. Either you have to call start method on it to make it scheduled for running. And another way is you may call the stop method that actually kills the thread, or rather that actually stops that thread. So any one approach you may take from this state newborn. When I am calling the start method, the thread is now scheduled. Fine. The thread is now scheduled. When it is in scheduled, that means the thread is in runnable state. Try to understand the difference between this running and runnable state. The thread which is in processor, that is in the running state, and the thread which not yet get any processor but waiting for the processor, maybe they are waiting in a queue, so that is the state which is called runnable. So I hope you can understand what is the difference between these two states, running and runnable. The thread which already gets the processor, rather the thread which is in processor, that means the thread is in running state. But if the thread is in waiting queue, a queue is definitely a queue is maintained, because thread 1, then thread 2, then thread 3, again thread 1, or again thread 2. So definitely a waiting queue must be maintained. So that state is called the runnable state. Fine. So I hope you understood what is the difference between running state and runnable state. And thing is that there is a yield method in between these two states that is defined by the thread class. What it does, actually yield method forcefully, if a thread is in running state, that means thread is in processor. Fine. So if a thread is in running state and you call the yield method on that particular thread, the thread relinquish its control to the next thread when it calls the yield method in it. Try to understand what is the functionality of this yield method, which is in between these two states, that is running state and runnable state. I'm explaining this later on once again. another state which is in block state. That means the thread is not in runnable. The thread not is in runnable or running state. It is in block state. What is the meaning of block state? That means the thread is in idle state. Try to understand what is the meaning of this idle state. Means thread is suspended for few milliseconds time. So they are not either in running state, not also in the runnable state. So there are the functions like suspend, sleep, wait. These are the functions which are used to make a thread from this runnable or running state to block state. And the thread, and the method, just like resume method or notify method, what this method does, this method actually resumes, or better to say, again the thread comes from block state to the runnable state. It cannot directly move to the running state, because we know runnable state is nothing but a queue. It's a waiting queue where threads are waiting to get processor, or rather to get execute. So from block state, thread can move to the runnable state, not directly to the running state, by using those methods, resume, notify, these methods. Fine. And from block state, a thread can also move to the dead state. That is the point, by calling stop method. So from newborn state, a thread can move to the dead state by calling stop method. From running/runnable state, a thread can move to the dead state again by calling stop method. And from block state also, thread can move to the dead state. Fine. So this is the overall explanation, rather description of thread life cycle. It's a newborn state. There is a running state, runnable state, block state, dead state. And everything is noted over here in detail. Look, I already mentioned from newborn state, a thread can move to the runnable state or move to the dead state. If it calls start method, then it moves to the runnable state. And if it calls stop method, then the thread moves to the dead state. What the runnable state means? The runnable state means that the thread is ready for execution and is waiting for the availability of the processor. In this thread, in this state, the thread has joined the queue of the threads that are waiting for execution. Fine. If all threads have the equal priority, then they are given time slots for execution in round robin fashion, that is first come, first serve manner. Round robin is an algorithm which is described in the concept of operating system, rather in concept of multitasking, where a circular, where the process says, rather what we know already what the process means, program which is in execution mode. The processes or gets executed in a multi-tasking manner, rather multi-tasking concept, rather time sliced is used over there. And the thing is that the order of this processor, rather order of these processes will be in processor is the manner of first come first serve basis. That means if the process P1 is the first come, then P1 gets processor. If then P2 comes, then P2 will get the processor. If then P3 comes, then P3 will get the processor. So the processor will be distributed among those processes based on their arrival of execution, rather arrival in the queue. So if the point says, if the thread doesn't have any priority questions, I'm coming to the priority of the thread in very next topic. If we consider all threads are of equal priority, so they must follow the round robin fashion. The thread that relinquishes control join the queue at the end and again waits for its turn. That I already discussed in the last class. So after completion of its time slice, they must have to leave the processor, and they has to it has to again wait for the processor in a queue. Fine. And this process of assigning time to the thread is known as time slicing. Fine. If we want a thread to relinquish control to another thread to equal priority before its turn comes, we can do so by this yield method that I just mentioned in today's lecture. Look, this is the pictorial representation. A running thread, this is the runnable threads. These are the queues. Fine, thread 1, thread 2, thread 3. They are waiting for the processor, and this is the processor. After completion its time slice, it will move from here to here. Try to understand. It will move from processor to queue for again getting back the processor for the execution of the remaining part of this thread. Now, if you call the yield method, so what is the consequence? Immediately, this thread relinquishes its control, rather leaves its control from processor, and it joins to the queue for next execution. And at the same time, what happened? The next thread that is waiting in the queue gets the processor, and it comes into the picture, rather it comes into the processor. So this is the function of this yield method that I already discussed, and this is the explanation of the yield method. Next, I am talking about the running state. Running state means the processor has given its time to the thread for its execution. The thread runs until it relinquishes control on its own, or it is preempted by a higher priority thread. Yes, a thread priority is concerned with this thread execution. If a higher priority thread comes into the picture, then automatically lower priority thread must leave the processor for higher priority thread. That I will discuss at the time of thread priority. A running thread may relinquish its control in one of the following situations. Yes. What are the situations? It has been suspended by using suspend method that I just discussed. Suspend means a thread is in running state, and if you want to suspend a thread for a few minutes or few milliseconds, so you have to call the suspend method. So when you are calling the suspend method on a thread, that means the thread moves from running state to which state? Block state, that I just discussed earlier. Thread moves from running state to block state. So suspend method can do this. So this is the running state. When you are calling suspend method, the thread is in suspended. That means it is not in the runnable state. Try to understand. This thread is in now block state. It is suspended. Then what it does, it will call resume method. I already mentioned about this method. It calls the resume method. When you call the resume method, the thread moves from suspended state to which state? Runnable state. Suspended state to runnable state. Try to remember the pictorial representations. So it is in running state. When it calls suspend method, it moves to the block state. And when it calls the resume method, from block state, it moves to the runnable state. Because directly it cannot get the processor. So it is not in the running state. It will move to the runnable state and wait for the processor. Fine. So this is the one situation. Another situation is it has been made to sleep. That is also a way to make the thread, rather move the thread to block state. Sleep method. Sleep method takes one parameter, that is time, which is in millisecond. Right? The time parameter is in millisecond, and this means the thread is in out of queue, rather not also in the runnable state. When a thread calls the sleep method, that means it is in block state, and it is suspended for that few milliseconds time, which is mentioned as a, or rather which is given as a parameter of the sleep method. And after that time elapsed, the thread automatically comes from block state to runnable state. Block state to runnable state. Look, this is the thread where it is in running state. When it calls sleep method with the parameter t is in millisecond, the thread moves from running state to suspended state. Fine. And after t milliseconds time, it automatically reaches from runnable state to suspended state to runnable state. And definitely when it is in runnable state in a queue, some point of time it will get the processor. That means the thread is in running state. So first situation is suspend and corresponding method is resume. Second situation is it is calling sleep method. And another situation is it has been told to wait until some event occurs. Fine. So that is the third step. Thread is moving from running to block state. Another approach. It is calling wait method. Wait method is used for what purpose? It has been told to wait until some event occurs. This is done using by this wait method. And when it calls a notify method, the thread can be scheduled to run again using notify method. So when notify method is called on this thread, so from waiting state it moves to the runnable state, and at some point of time it will definitely get the processor, and that means the thread moves from runnable to running state. So from a running state to block state, this is the entire picture. How a thread moves from running state to runnable, running state to block state, and from block state to runnable state. So a thread is said to be block state when it is prevented from entering into the runnable state and subsequently the running state. This happens when a thread is suspended, sleeping, or waiting in order to satisfy certain requirement. A block thread is considered not runnable but not dead, and therefore fully qualified to run again. So I hope you understood what is the meaning of this block state and how we can reach block state from a running thread. Next part is the dead state. You may call stop method, and I just mentioned from newborn state a thread can move to the dead state. From running or runnable state, a thread can move to the dead state. And from a block state also, a thread can move to the dead state. So how they move, how they can move? If you want to do it explicitly, rather forcefully, you have to call the stop method on it. And the normal death of a thread is when the thread gets executed fully. When the execution is complete, automatically the thread moves from running state to dead state, right? So every thread has a life cycle. Running thread ends its life cycle when it has completed executing its run method, and it is a natural death. We can kill it by sending the stop message to it at any step, thus causing a premature death of it. Thread can be killed as soon as it is born, or while it is running, or even when it is in block state, not runnable condition, that is in block state. So that I just mentioned. Fine. So this is the life cycle of thread that I just discussed. Newborn state, running state, runnable state, block state, and dead state. And this is a very important question of your syllabus. Next, I'm moving to the programming part of a thread. Let me share the screen with you. This program, I modified a bit. This is actually the program that I discussed in my last lecture. And I told at that time that there may be because the thread is getting processed. It's not, when the thread will get processed, it is not in our hand. So that's why at different execution, we may get different output of the same program. So here what we have done, we just implemented those methods that I just discussed, few methods, not all, in this last program. So last program, I just get modified few. Look, last program, this part was not there right now. I'm just commenting the part that I have modified in this program. I'm introducing the yield method over here. Fine. In the second thread, I introduce a sleep method. Try to understand. I introduced a sleep method over here. That part I commented. And no more changes I have done for the last program. So if you execute the program, you will get the output as previous, rather as last lecture that I shown you. Look, threads are getting executed I, J, K in different manner. First I, 1, 2, then K gets processed. Rather thread gets processed, thread C gets processed. So K executed, then again I, then again J. I for thread A, J for thread B, and K for thread C. So one after another, the threads are getting executed. Here what we have done, I have introduced two methods that we just learned. Number one method is yield method. What is the purpose of this yield method I just discussed? The yield method purpose is, when I'm calling this yield method on a thread, that means the thread that is in the runnable state, is in running state, relinquishes its control, and the thread immediately moves to the which state? Runnable state. Fine. And definitely the next thread, which is in queue, will get the processor. That is the purpose of the yield method. And what is the sleep method does? The sleep method I just discussed. From running thread, we can suspend a thread for a stipulated time that I passed as a parameter of the sleep method, and that the parameter is in milliseconds time. 1000, when I'm writing 1000, that means 1000 milliseconds time. And this sleep method says when the 1000 millisecond time gets elapsed, the automatically thread, rather this thread which is in block state by calling the sleep method, is automatically back to the P state, runnable state. So let me execute the program and try to explain about the output of this program. Look, exit main thread, fine. Then thread C gets its processor. K1, K2, K3, K4, K5. Why thread C gets processed? Because look at the point, when thread A gets processed, thread A gets processed. When the value of I is 3, it will leaves its control to the next thread. And for thread B, what I have done, when the value of J is 3, the thread moves to the block state for 1000 milliseconds time. And if you view the code thoroughly, one more thing I have done, when I'm calling this sleep method, that must be written inside try block. Fine. Because this sleep method throws an exception which is interrupted exception, which is called interrupted exception. Though I have not mentioned the name over here, I have called, rather I have declared only exception class. But the type of the exception this sleep method can throw is an interrupted exception. Try to understand. It's an interrupted exception. And as because the sleep method throws an interrupted exception, that's why I must have to call this sleep method inside try block. If you not call it inside try block, you will get an error, rather compile time error, because it's a type of, what type of exception? It's a type of checked exception. If you don't handle it, or if you don't declare it, as per our previous knowledge, we can say yes, at the compilation time you may get an error. Definitely will get an error if you not write it inside try block, or rather handle it using catch block. So again, I am executing the program to, we can get different output. Yes, we are getting different output. Look the output status. Here, exit from main thread, then J equal to 1. That means second thread gets its processor. K equal to 1, third thread, first thread, thread A, thread B, fine. I equal to 2, fine. When J equal to 3, look, I equal to 2, when I equal to 3, it leaves its control. And when J equal to 3, when I equal to 3, it leaves its control, right? It's because it's calling the yield method, fine. It leaves its control to say K. Then again, it comes into the I. Why? Because the J thread, that is sleeping. Right now it is sleeping for 1000 milliseconds. So at that time, I and K gets the processor alternative way, rather in alternative manner. So no output regarding J is coming in this period. Look, I2, K4, I3, K5, I4, exit from thread C. So B is not in picture. B is not in picture. Look, now this 1000 milliseconds time is over. Then thread B comes into the picture and executed the remaining part, that is J3, 4, 5, that is SOPLN J. That line also not gets printed when it goes to the block state. So that is the explanation of this output. You may get different execution output for the next execution. So this is the implementations of this yield method and sleep method. Probably you can understood this. So one is for the moving one thread from running state to runnable state, and another method which is used to block a thread, that is from running state to block state, move a thread from running to block state. Fine. So this is the program that I just discussed. This is the program that I just discussed. Now I'm moving to the part that is the thread priority. Fine. What is this thread priority? Just I mentioned earlier that thread, each and every thread has its own priority. Each and every thread has its own priority. The priority value of thread can be categorized into 3 standard values. One is min priority, another one is non-priority, another one is max priority. And the priority value of the thread ranges from 1 to 10. And if you don't set any priority for a thread, the priority of the thread can be considered as a non-priority, that is the value 5. The mean priority value, that is 1. Normally, in other cases, we know the priority value is higher, rather priority is high when the value is lesser, and when the priority value is 1, it's actually the highest priority. It means the highest priority. But in case of thread priority, no, this is not that type of. 1 priority means value 1 means it is the lowest priority. And at the same time, we can say if the priority value is 10, that means the priority of thread is the highest one. Fine. And definitely the thread priority is basically the thread priority. What I want to say, it affects the order in which it is scheduled for running. It affects the order in which is the schedule for running. Suppose a thread which is running in the processor maybe of non-priority, rather the priority value 5. When another thread comes into the picture, say it has the max priority, definitely the non-priority thread or the lower priority thread gives the processor and to the higher priority thread. So definitely the priority affects the order in which it is scheduled. And the priority which have the threads which have the same priority, they are given to the equal treatment by the Java scheduler. Fine. And at the same time, I must say there is a method that is set priority. Using the set priority, we can set a priority value of a thread. And similarly, we have another method which is called get priority. And using that get priority method, we can retrieve the priority value of a thread. Fine. So using set priority, we can set a priority of a thread. And using get priority method, we can retrieve the priority. We can retrieve the value of the priority of a thread. And the thread priority value lies between 1 to 10. That is the point. Thread priority value lies between 1 to 10. 1 is the mean priority, 5 is the non-priority, and 10 is the max priority. But nowadays, I have implemented this concept in one program that is written inside this note that I have implemented. I've written over here what I have implemented. Look, I'm sharing the programming screen with you. Yes. Look what I have done. The last program, that is 3 threads, thread A, thread B, and thread C. One is from class A, another is from class B, another one is class C. So I've created an object of class A, B, and C. That means the threads are in newborn state. And before running, I'm setting the priority of those thread. So thread dot max priority. So that means I'm setting the value of, rather thread of priority of OB1, that is the first thread. I'm giving the maximum priority to it, that is value 10. Fine. And at the same time, I am printing the value of OB1 dot get priority. That means I'm getting the value of that priority of thread OB1. Fine. Next, what I've done, OB1 dot start. Fine, OB2 dot start and OB3 dot start. Before that, I have done two things. One is OB2 dot get priority plus 1. What is the meaning of this? That means the OB2 get priority plus 1 means by using set priority, what we can do? We can set the priority of a thread. Inside this, I passed a parameter OB2 dot get priority. That is when the thread is created, if the priority value is not mentioned, it normally gets the non-priority value, that is 5. So when I'm telling OB2 dot get priority, that means it is 5 plus 1, 6. So the priority value of OB2 is now 6. And I'm setting the OB3 priority value, that is min priority, say it is 1. So I'm commenting that part because this execution, when I'm executing this program, I'm not getting any effect regarding the priority. Why? Because nowadays a problem arises. Thread priority doesn't guarantee the execution order. It comes into play when the resources are limited. Try to understand. Thread priority doesn't guarantee it in the execution order nowadays because it comes into play when resources are limited. So if the system is running into constraints due to the memory or CPU, then the higher priority thread will run first. Assuming that we have sufficient system resources, normally in our machine we have enough system resources regarding memory, regarding primary memory, secondary memory. Primary memory is required, secondary memory is not required. So we have enough memory, enough resources. So that's why we are not getting any effect. We have no system constraints. So that's why we are not getting any effect when we are implementing thread priority. But yes, in some machines you can get the output of this effect, rather, so of this priority value. Maybe in your machine you may get the effect of these priority values, but in my machine, when I'm executing the program, I'm not getting any effect because I have set the priority value of this thread A as max priority. So according to the rule, it should be executed first. It should be executed first, then the next thread needs to be executed. But it is not happening in the output. Look. Yes, now it is fine. Now it is running fine. But earlier, when I have executed this program, I haven't got this type of output. This is the desired output because look, the priority value is 10 of this thread. That means the first needs to be thread A gets executed. Now it is fine, but you will not may always get this output as desired because if the resources is available, so thread priority will not affect in the output stream. Fine. Because earlier when I executed this program, I got the different output, which is not at all affecting the priority to the thread. So that is the point needs to be noted. Fine. So I hope you understood what the thread priority is and how you can implement this thread priority in your program. Next, I will discuss one more thing, that is how that is the point, how the second approach, that is how we can use this runnable interface to create a thread. This is the last topic that I discussed of today's lecture. That is how the runnable interface can be used to create a thread and to execute a thread. We already discussed about the extending thread class approach. Fine. There are two approaches. Number one is extending thread class, and second approach is that is implementing runnable interface. So now I'm going to discuss how this implementing runnable interface approach can be used to execute a thread, rather to create a thread and to execute a thread. Look here, instead of extending a thread class, I am implementing this runnable method. So class A implements runnable. So this is a bit similar to my last program, that is the program that I discussed in the last class, last lecture. And this is the run method, as because as per the previous rule, run method is the heart of the thread. So inside run method, I have written the required code of the thread, that is I equal to 125 SOPLN I. Similarly, for the second thread, when I'm creating class B implements runnable interface, and this is the run method, J equal to 1 to 5, and class C implements runnable interface, K equal to 1 to 5. I hope this much you have no doubt. Thing is that, or rather problem is that, we can create the object of this class A, B, and C. Fine, try to understand. I can create an object if this thread A, B, and C. Rather class A, B, and C, not thread A, B, and C. Just like earlier situation. And the thread class, the method run, not run, sorry, the method start, which actually moves the thread from newborn state to running state, it is defined under the thread class. It is not defined under this runnable interface. That is the point needs to be noted. So you cannot call a run method on an object of class A, B, or C. Why? Because the A, B, and C, they are implementing the runnable interface. And runnable interface has no start method to start a thread. So what do you have to do? You have to create a thread object again. You have to create a thread object again, just like by calling this new thread. Try to understand. New thread is basically used to create a thread object, right? And inside this constructor thread, we are passing new A. Try to understand. What is the meaning of this new A? New A means it is an object of class A. Which one is the class A? Class A is a class where we have implemented runnable interface. And on this thread object, we can call the start method. On the thread object, we can call the start method. So we have to pass what? We have to pass the object of that class where runnable interface implemented as a parameter of a thread constructor. So this line can be written in two steps also. If I break this line into two, so the line will be like this. Class A, I'm creating an object of class A OB equal to new A. Fine. So what is this A? This A is a class where we implemented that runnable interface. Fine. Now, I am creating an object of a thread class, better to say. So thread class object, thread OB1 equal to new thread, fine, where we passed that object, rather that object where we use this runnable interface as a parameter. Now we can call this start method on this OB1, because start method is defined under the thread class. It is not defined under this runnable interface. That's why when we are implementing this runnable interface, we must have to create an object of a thread class, and we have to pass the object of that runnable interface implemented class as a parameter to that thread constructor. Just like this. We have created an object of class A first. A is the class where we implemented runnable interface. That object will be passed as a parameter of a thread constructor, and thread object gets created, that is OB1. Now we can call start method on OB1 as because OB1 is an object of thread class. In the similar manner, we have actually writing these 3 lines into one single line. So that's why it looks complex. Actually, these are basically these 3 steps. You have to create an object of that class. We have to pass that object as a constructor of as a parameter of the thread constructor, and then we have to call the start method on that thread object. And if you execute the program, you will get that multi-threading result on this of this output. Look, fine. No such differences I am getting here. The threading effect is not yet reflecting, because J gets executed, then entire K gets executed, then I gets executed. Fine. Again, I am executing the same file. Look, bit multi-threading result. I, then K, then J, then again K, then I, then J. So it's a multi-threading operation has been performed over here. So this is the way through which we can use the runnable interface in our program. Rather, we can use the runnable interface to create n number of threads, and that can be executed by calling this start method. So I hope this much is clear to you all. So I'm concluding today's lecture over here. Thank you. Thank you very much.